Hey everyone, welcome again to room 233, the orange room. Today I'm going to be talking to you about senses, about how your nervous system can sense different things going on around you or within your body and make sense of them as electric signals. Now, I don't know about you, but I've got a sense this is going to be some really interesting stuff. Now, unless you are Spider-Man or Haley Joe Osment, you've probably been told that you have 5 senses. We're going to dispel that today. We're going to cover senses in general and learn that you have many more than 5 senses. That myth comes up because touch is often referred to as one sense as a whole, but really there are many types of touch. Things like texture, pressure, vibrations, temperature, pain. And so we're going to tease those out today. We're going to focus on touch after we go over senses in general. So in general, senses are ways to detect a change in the external or internal environment, internal being what's going on inside your body. You need receptors for that. Receptors are specialized cells or structures within the body that can turn those different stimuli from the environment, external or internal, into a signal that the nervous system can interpret and understand, an electric signal, an action potential. Receptors can be classified by what stimulus gets them to be triggered and produce an electric signal, an action potential. There are photoreceptors, which are sensitive to light, and that's for your sense of vision. There are chemoreceptors that respond to certain chemicals, and those would primarily be for taste and smell, although there are some chemoreceptors we'll talk about later, which are involved in pain sensations. Thermoreceptors are one of the touch receptors that you typically lump into the sense of touch, but they are distinct from others in that they respond to changes in either warmth or coolness. Nociceptors are receptors that are responsible for pain, and there are different types of nociceptors we'll cover a little bit later. And finally, mechanoreceptors are ones that respond to movement or position. And that's a very wide variety of receptors, and they're used in a number of different ways to produce different sensations, everything from hearing to balance to body position, texture, vibrations. Adaptation is a situation where the nervous system becomes accustomed to or less sensitive to a sustained stimulus. So something that continually stimulates a receptor or a pathway over time will stimulate it less in general. There are some receptors that show little to no adaptation, but the ones that you can think of right now would be warmth and cold. Those show adaptation because if you get into a hot shower right away, you notice that over time it doesn't feel as hot. Or if you get into cold water at the beach or the pool, over time it doesn't feel as cold. And similarly, the touch receptors in your skin, you don't feel your clothes on you all of the time because they have shown adaptation. Now, adaptation can work in one of two ways. They can work on the receptor cell itself, or the area of the central nervous system might become less sensitive to stimulus from that receptor cell. We'll next look at the different types of touch sensations and receptors. There are 3 touch receptors aside from pain that we'll discuss. First, free nerve endings. Free nerve endings are right underneath the outer layer of skin, or sometimes going into the outer layer of skin, the epidermis. And that's for like itching sensations or very, very light touch. Next are called Meissner's corpuscles. These are near the surface of the dermis, right below the epidermis, and they are for light touch and texture. And then deeper down, lower in the dermis, maybe in the subcutaneous fatty tissue or in the synovial joints, are Pacinian corpuscles, and they are meant to sense deep pressure, deep squeezing, or vibrations. For temperature, you have thermoreceptors. There are some that respond to warmth that are responsive from 77 to 113 degrees Fahrenheit. And there are some that are responsible to give you the sensation of cool. And that would start activating at 68 degrees Fahrenheit all the way down to 50 degrees. Now, outside of those temperature ranges, you actually feel pain associated with those temperature ranges. Feeling something that is over 113 degrees Fahrenheit will not just feel warm, but it will feel warm and painful, aka hot or burning. Similarly, feeling something or putting your hand into water that is lower than 50 degrees Fahrenheit will cause a sensation of coolness, but also pain, aka freezing. Proprioception is how you can close your eyes and know where your limbs are, what you are doing. I know that I'm giving thumbs up, even though I can't see my thumbs. And it's because of things called muscle spindle fibers and Golgi tendon organs. Muscle spindle fibers are embedded into muscles, and they send signals back to your brain about if that muscle is contracting. And then your brain can put that together and figure out, based on which muscles are contracting, what that limb is doing. Golgi tendon organs are embedded in tendons, the parts that connect the muscles to bones or other muscles. And what they do is they sense if that tendon is stretching, if it's overstretching, because tendons could overstretch. Many muscles are strong enough to rip their tendons, but the Golgi tendon organ inhibits that muscle or stops it from contracting as strongly so the tendon does not rip. And last, baroreceptors sense pressure, and they are in the arteries that are near the heart, and they sense blood pressure if the blood pressure is too high or too low. What I'm going to cover last today are the different ways that pain can be sensed. The different types of receptors that sense and transmit pain are collectively called nociceptors, though there are different types. Nociceptors could be just free nerve endings that are very sensitive. They could be responding to damage to them, damage to nearby tissues where chemicals might be released, or it could be an overstimulation of a normal receptor. And so a normal receptor, like the warm receptors, overstimulation of those over 113 would then turn that into a nociceptor. In addition to tissue damage, releasing some chemicals that can be sensed as pain, there are things called prostaglandins that are released. Prostaglandins are chemicals that increase the sensitivity of nociceptors, and so the pain sensation is more intense. When you take ibuprofen or aspirin, those work in part by lowering the production of prostaglandins and therefore blocking that signal to make the pain receptors more sensitive. When there's damage to an internal organ, that is called visceral pain. Visceral pain is different than surface pain because small-scale damage to an internal organ might not cause a sensation of visceral pain. However, widespread damage or stimulation of that organ would. The example that is in a lot of sources is that if a surgeon is operating on someone's intestines and there's a small-scale damage or cut to an intestine, it might not cause the person to respond even if they're awake, but widespread stimulation of the intestines, stretching them or blocking blood flow for an extended amount of time would cause a sense of pain in that internal organ. And that's generally because of mechanoreceptors, whether the organ is being distorted in some way, stretched, squeezed, or chemoreceptors that sense oxygen levels. And so if blood is not getting to that area and there are receptors for oxygen and they can sense that there's not enough oxygen or nutrients getting to that area because of blood flow being reduced, that can cause pain. Visceral pain can also sometimes be called referred pain. Sometimes when there's damage or injury to an internal organ, instead of feeling it as coming from inside, you could feel it on your skin. That's called referred pain. And that is because some visceral pain receptors share nerve pathways with surface skin pain receptors. And so your body can't tell the difference between damage to your heart and damage to a certain part of your skin. Here, you can see mapping, a color-coded map that shows where referred pain could be on the body based on the internal organ. Well, I hope that was clear enough and interesting. One of the main takeaways I want you to have from this is that you don't have just 5 senses, but that touch really is multiple different things lumped together. Next time, we'll cover the special senses and learn specifically more about sight, hearing, equilibrium or movement, how you can sense when you are moving, smell and taste. Thanks for being here, and I'll see you all in class.